The first of the two aspects that I particularly want to focus on are that the regulators are to some extent throwing out value at risk and saying they want to replace it with expected shortfall. And, we'll make things a bit more precise in a moment, but what they're saying is that instead of using value at risk with a 99% confidence level, they're actually going to use expected shortfall with a 97.5% confidence level. And it turns out that if you have a normal distribution, those two are almost exactly the same. In other words, you're going to get the same. For those of you who don't know what expected shortfall is, it's on my next slide. But it turns out that VAR, value at risk with 99%, is equivalent to expected shortfall with 97.5% if we're talking about normal distributions. If we've got distributions with fatter tails than the normal distribution, then you'll find the expected shortfall measure is higher. So, perhaps it's about time we defined what we mean by these measures. Value at risk, abbreviated VAR, is the loss level that will not be exceeded with a specified probability. So one way of thinking about that is you're just asking the simple question, how bad can things get? What's the worst that can happen? Well, we know that all sorts of horrible things could happen. We could have, Third World War, half the planet being destroyed and that sort of thing. But so you have to sort of define some confidence level, and you have to define some time horizon. But you're saying just how bad, what's the percentile of the distribution that corresponds to that confidence level that I'm interested in, which, as we said, was 99% for the original Basel capital requirements. Now, expected shortfall is the expected loss given that the loss is greater than the VAR value, VAR level. It's also called CVAR and tail loss. So what you're saying is, expressed crudely, if things do get bad, just how bad will it get? In other words, if we're in that tail of the distribution, what is our expected loss? Just how bad might the loss be? So here's a picture of why two distributions or two loss distributions can give the same value at risk, but actually different expected shortfalls. If we look at the top distribution, it's a sort of fairly bell-shaped, normalish kind of looking distribution, and we've got, I can't see very well here, but got the VAR level there. The two distributions have got the same VAR level, so they've got the same probability mass in the tails there. Okay, there's the same probability of the loss exceeding the VAR level in both cases. These distributions are constructed so that the positive axis is a gain, the negative axis is a loss. So, we're talking when we're in the tail of the distribution about losses. And but you can see that if we wind up in the tail of the distribution, you can see that the loss is going to be a lot worse for the lower distribution than the upper distribution.